Now here this looks like a u substitution, but it's a little different because look, u is t minus 1, right? Now du would just be 1 dt, that's fine. So you have something to replace t minus 1, that. You have something to replace dt, du, but you have nothing to replace t. So for that reason, take this equation and isolate t. So we know that u equals t minus 1. If I add 1 to the other side, it tells you that 1 plus u equals t, so t equals u plus 1. So now I have something to replace everybody here, integral. So here is my square root. T minus 1 is u. And then t is u plus 1. And then dt is du. And you might think that nothing has changed, but I do, because before, the integral, or the square root, had 2 items. Now the square root has 1 item. And so it's a little friendlier to deal with. And let me just rewrite it as such. And now let me actually distribute. So this is u to the 3 halves plus u to the 1 half. Because there's a 1 here, you add the exponents, you get that. Keep your du in place. And now do term by term integration like we've been doing. Add 1 and then divide by the new power or multiply by the reciprocal of the new power. I believe this is 2/5 u to the 5 halves plus 2/3 u to the 3 halves plus c. Let's see, do I believe this? The derivative is that, the derivative is that. This looks good. It's indefinite, so this is a plus c. And I replace the u's with t minus 1. So 2/5 t minus 1 to the 5 halves plus 2/3 t minus 1, sloppy writing, to the 3 halves plus c. So this is legit, or if you wanted, you could write this with radicals as such here, like that, plus 2/3, and then this would be a square root of t minus 1 to the power of 3 plus c. Either one should get you 100%, right? Let's see, moving on here. Okay, here, another u substitution, but what are you going to let u equal? You want to let u be the thing that the derivative of it appears there as well. So for that reason, I'm going to let u be ln of t, and I'll tell you why. The derivative of ln of t is 1 over t dt, and I see that. Like the 1 over t is right there, right? And the dt is just there. So I think this is a perfect match. If you want, you can rewrite this. Rewrite this as 1 over t times 1 over ln of t times dt. And now you can better see that everyone gets perfectly replaced. So for instance, this middle piece, 1 over ln t, well, I got to keep the 1, but the denominator ln t is just u. And then 1 over t dt is right there, that's just du. And then we saw this earlier today, how I don't even need this anymore because I'm going to take the integral, the antiderivative of that, which is just natural log of u plus c. But we know what u is. U is ln of t. So this is natural log, absolute value, natural log, absolute value of t. Okay, plus c. And let's see, so the next one here. So this one's not bad because you can see that this is going to be, your u is going to be the exponent because the derivative is going to be a power of 2, which this is. So your du would be 6x squared dx, but I want a 3x squared instead of a 6x squared. So divide by 2 and multiply by half, same thing. So that 1/2 du equals 3x squared dx. And now this perfectly matches the pieces there. So this would be the integral of e to the u du with the 1/2 in the front, right? Because that's e, that's u, du, the 1/2 du covered these pieces. This looks good. 1/2. What's the antiderivative of e to the u? Itself. Give me a plus c. But now u is that there. And so here we go. Right? The derivative of that is that up there. And let's see here. Oh, this is a fun one. So what are you going to let u equal? Allow u to be the thing whose derivative you see. This is really sneaky. But I propose that that's going to be u. If you look at it carefully, if you stare at it long enough, this is going to be a chain rule. Let's see why. So I propose that this is u. Now let's see. Let's take the derivative of this. So this has layers. So first you take the derivative of this, and then you take the derivative of that. So when you take the derivative of cosine, it's going to be negative sine, but the angle stays the same, right? When you're working on the outer layer, that stays the same. It's just then when you're done with the outer layer, you then multiply by the derivative of the inner layer. And the derivative of sine is cosine x, and just add on a dx. And if you want, look, kick the negative to this side, because now you see that this perfectly matches the leftover pieces. Sine of sine, boom, boom, cosine dx, right? And this is going to be that u there. So we still keep this outer layer. It's just that the stuff in here, that got replaced by u. And then all these pieces, that's a du, but just put the negative in the front, right? Okay, and now keep the negative in the front. The antiderivative of sine is actually negative cosine, right? Because the derivative of negative cosine is positive sine. And the double negatives happen to just conveniently go away. And now what? Let's see. So now, well, it's still u, Mr. Lee. It's still a u. But now we can drop in u into there. Put your plus c. So final answer, cosine of sine of x, close two doors, plus c. And now for this last one, you have to remember something. What if you have something like 5 to the power of x? What would be the derivative of something like 5 to the power of x? The derivative of something like that would be, first of all, itself, and then times the natural log of whatever the base is, 5. So for instance, what about like 3x squared? The derivative of 3x of 3 to the power of x squared would be, first of all, itself times ln of 3 times 2x, because it's the derivative of the exponent as well, right? So it has like a little chain to it. So what if you saw something like this? What would be the antiderivative of something like 7 to the x times ln of 7 dx? Can we agree that the antiderivative of that would just be 7 to the x, right? Because the derivative of this would be itself with ln of 7. So if I have something that looks like that, I can go immediately here. That's kind of what we have here, right? That kind of looks like that, but this is missing something. This is missing that ln piece. I really wish that I had an ln3 right there. I really want an ln3 right there. So watch what I do. 3 to the t times 1 times dt. I can always multiply by 1 and get away with it because I've changed nothing. Now what I'm going to do is this. I'm going to multiply by 1, okay? I'm going to put 1 right there. Watch what I do. I'm going to multiply by ln of 3 times 1 over ln of 3. Because, hey, how much is this? This is 1, right? This is 1. And the reason I've done that is to keep this and put this in the front. I keep what I want beside it, and the extra piece, which is unwanted but necessary, goes in the front. I'll dump that out there. And so what would be left inside here? Notice that we have manipulated this to our satisfaction. And now this here, we know what that is. That's just like that there, right? That's just like that there. It's the definition of the antiderivative. So that would be 3 to the t. But you got to keep this piece. You can't just throw it away. It has to be part of your answer. And then just put your plus c. And if you want to just write this as one piece, that's fine. However, finished.